In 2014, a helicopter was flying over Siberia when the pilot's attention was drawn to a strange and unusual object on the ground. It was a massive sinkhole, 80 feet wide and as deep as a 15-story building. The pilot circled the sinkhole a few times, took some photos, and then left. However, when these photos were posted online, the news spread like wildfire across the world. Many scientists, geologists, and Arctic researchers had never seen such a large sinkhole before, especially one that appeared overnight. Its volume was so large that it could easily contain the water of 10 Olympic-sized swimming pools. But how it formed so suddenly was a mystery to everyone, at least based on the photos. The area, located in the northern part of Russia, Siberia, is known as the Yamal Peninsula. Due to extreme conditions, the population here is sparse, mostly consisting of a few thousand nomads. In their language, Yamal means the end of the land. Following the discovery of this sinkhole, Arctic geologists began to focus their attention on the area. While sinkholes have appeared in various parts of the world, including in urban areas, swallowing cars, and even entire houses, they are typically formed due to water erosion weakening the ground beneath. However, geologists noted that the Yamal sinkhole was unusual. Unlike typical sinkholes which have flat borders, this one had raised edges and debris scattered around. Rocks were found strewn up to 900 meters away. Such debris is usually seen where an asteroid has struck, but no evidence of an asteroid impact was found inside the sinkhole. Scientists hypothesized that it could only have been formed by a significant natural explosion. Normally, underground volcanic activity could cause such explosions, but there was no lava or volcanic rock found near the sinkhole. The rocks nearby did not seem to be related to any volcanic activity. So, how did this crater-like sinkhole form? To find out, scientists collected air, water, and soil samples from inside the sinkhole. The tests revealed high levels of methane gas. Methane, a natural gas used for cooking and heating, is highly combustible when mixed with air. It was then hypothesized that the sinkhole was formed due to methane gas rising from the ground. This mystery seemed solved for scientists, and their interest in further investigation waned. However, before they could determine the source of the methane, 8 more sinkholes were discovered in the Yamal Peninsula, all similar in nature, suggesting explosions. Satellite images revealed that these sinkholes had been forming one after another since 2014. The rapid formation of these sinkholes was alarming, but even more concerning was their apparent link to climate change. The first sinkhole appeared in 2014, and the following year, Siberia recorded unusually high temperatures. All the sinkholes formed during periods of high temperatures. Since the early 19th century, the average global temperature has increased by 1 degree Celsius, but in the Arctic Circle, the increase has been even more pronounced at 2 degrees Celsius in the last 100 years. This led scientists to ponder the connection between these sinkholes, climate change, and the future of the Earth if such events continued to occur. Meanwhile, a separate research team in the Arctic Circle, far from Yamal, made another discovery in Alaska's Isia Lake. The lake had been exhibiting unusual behavior for months, with bubbles emerging as if the water was boiling. Upon investigation, it was found that these were methane gas bubbles. While minor methane leaks are common in the Arctic, the volume of methane being released from Isia Lake was unprecedented. The research team decided to investigate the source of the methane in the lake. Although Isia Lake is generally 3 feet deep, the area from where the bubbles were emerging was much deeper, making it impossible for divers to explore. Using sonar scanning, they created a 3D model of the lake's bottom, revealing that the lake was 50 feet deep at that spot. Both the Yamal sinkholes and the Isia Lake methane leaks were occurring in the Arctic Circle and were situated on permafrost. Permafrost is a type of ground that is permanently frozen. It covers large areas in Russia, Canada, and Alaska. Recent research showed that due to rising temperatures in the Arctic Circle, permafrost is starting to melt. The implications of melting permafrost are significant, as it underlies vast landscapes, including forests, rivers, and human-made structures. Evidence of this melting was found 600 kilometers away from Isia Lake in Alaska's Foxtown. Here, the trees in a forest standing on permafrost had begun to lean to one side as if their roots were weakening. Additionally, the ground had sunken in places, creating unusual holes. This phenomenon only began after 2018, but what is the link between melting permafrost, methane gas, and the Yamal sinkholes? To understand this, a tunnel was dug into the permafrost in Fairbanks, Alaska. Inside, scientists found not only frozen ground but also the preserved remains of ancient animals like mammoths and steppe bisons, as well as ancient grass. This indicated that a large amount of organic matter, containing carbon, was preserved in the permafrost. As plants grow, they absorb carbon dioxide from the atmosphere. When they die, some of this carbon is released back into the atmosphere during decomposition. However, in the Arctic Circle, the freezing temperatures slow down the decomposition process, leading to a large amount of organic matter, and therefore carbon, being preserved in the permafrost over thousands of years. Experts believe that the amount of carbon in the Arctic permafrost might be more than the total carbon in the Earth's atmosphere. As the permafrost melts due to rising global temperatures, this organic matter begins to decompose. Bacteria consume the carbon for energy and release methane gas as a byproduct. Additionally, the melting permafrost softens the ground, allowing trapped methane gas to escape more easily. The sinkholes are formed when this gas finds a weak point on the surface and bursts out. The increasing number of sinkholes in the Arctic Circle is a cause for concern, and so far, no solution has been found. Even with efforts to control global warming, stopping the melting of permafrost seems impossible. This situation poses serious questions about the connection between permafrost melting, methane gas emissions, and climate change, as well as the future of the Earth if these phenomena continue.